Let's consider one more question from the miscellaneous exercise of chapter 1, question number 17. The question says, let A be the set containing 1, 2 and 3. Then how many number of equivalence relations containing 1, 2 be formed? So you have the choices of 1, 2, 3 or 4. So if I start thinking about it, then to begin with, if I say R, and let's call it R1, to be one relation which I want to have which satisfies all these conditions. So for it to be reflexive, I must have 1, 1, 2, 2 and 3, 3. So by just simply following the reflexive conditions, these are the 3 ordered pairs that can be listed. If this relation is to contain 1, 2, then for it to be an equivalence relation, I must have 2, 1. So relation is symmetric, and also 1 is related to 2, 2 is related to 1, and I have a 1, 1 in the set. So if I just consider this relation, then it is an equivalence relation. So we have found one such relation which satisfies the given condition. The question says, do we have more? So yes, let's try that. What are the other elements that I can add to this relation? So suppose we look back at, okay, how many elements are there in our relation, that is A cross A? So we have 9 elements. I have only considered 5 here. So suppose we add the element say 2, 3 to this set. So if I add 2, 3, then I also have to add 3, 2. They both have to be there, because then only the relation will be symmetric. But the moment I do that, do I also need to keep something in mind? Think about it. Give a little pause to the video and figure out what is the missing component. For this new relation, which I am going to call say R2, to be an equivalence relation. Hope you did consider. So suppose I write R2 to be 1, 1, 2, 2, 3, 3. These elements have to be there. Also 1, 2 and 2, 1. Now if we add 2, 3 and 3, 2, then to make sure that this remains an equivalence relation, that is the transitive part of this condition is satisfied, do I need to consider something else? Think about that. 1 is related to 2, 2 is related to 3, and therefore I must have 1, 3 in this relation. The moment I add 1, 3 in this relation, then to keep the symmetric aspect, I have to have its partner 3, 1. And so what do we end up with? We have actually covered all the 9 elements, and therefore this is definitely the largest equivalence relation, which is the universal relation. That gives us the condition, that is the relation is equivalence, contains 1, 2. So how many relations can be formed satisfying the given condition? The answer would be yes. The answer is going to be nothing but 2. So in this particular question, this is your correct choice.